Everyone. We are working through chapter 11. We left off on the proof of the sum of the x deviations squared, right? If you remember, last time we talked about the definition of SXX. All right, so we have SXX, the sum of the x deviations squared. We want to move from left to right. So we start with the left-hand side. Summation I equals 1 to n of the xi minus x bar squared. And we get that to be the summation of the xi squared minus 2 times the summation of the xi x bars plus the summation I equals 1 to n of the x bar squared. All right, we continue on to the summation of the xi squareds minus 2. I'm going to pull out that x bar because there's no I associated with it. Summation of the xi's plus, now I'm going to do a trick here. If we sum something that has nothing to do with I in times, well, that just turns into n x bar squared. All right, that's a good trick to know. We are writing again xi squared minus 2x bar. I'm going to multiply by n over n because that just equals 1. Xi, I equals 1 to n plus n x bar squared. And then I'm going to recognize that the summation of xi divided by n, well, that's just another x bar. So all of this ends up being the summation I equals 1 to n of the xi squared minus 2 n x bar squared, check my math, plus n x bar squared, and that's going to reduce to be summation xi squared minus n x bar squared. Looking good so far. All right, we're going to convert back from the x bars to the xi's. So we'll take I equals 1 to n of the xi squareds minus n, and then we have that square piece. We have the x bars in here. So this is the summation I equals 1 to n of the xi over n. Okay, looking good. We're looking very, very close to what we would like it to be. So all of this is going to equal summation I equals 1 to n of the xi squareds minus, well, we have n over n squared times the summation I equals 1 to n of the xi's squared. All right, and now we are there. That results in I equals 1 to n xi squared minus the summation of xi quantity squared over n. And we have finished our proof, right? QED. Okay, I want you to practice the same type of proof with SYY. Those are the sum of the y deviations squared. So in general, your homework is going to prove that the summation I equals 1 to n of the yi minus y bar squared is equal to the summation of yi squared minus summation of the yi squared over n. Okay, one thing to note is that it does matter whether or not you have parentheses here, because in one case, just remind yourself, if we had the values of yi equal to 1, 2, 3, so y1 would equal 1, y2 would equal 2, y3 would equal 3. Just do a quick spot check so you know that the summation of 1 squared plus 2 squared plus 3 squared, right? That would be our summation of the yi squareds. That's different than the summation of the yi's squared, which would be 1 plus 2 plus 3 squared. So just go ahead and check so you know the difference in notation. Okay, so this is an aside. Okay. Homework for you to do. Okay. All right, let's do another proof of the sum of the x deviations times the y deviations. All right, one foot in front of the other. Let's start on the left-hand side and move to the right-hand side. So we're looking at SXY in this case. Okay, we have the summation I equals 1 to n of xi times yi minus xi y bar minus yi x bar plus x bar y bar. All right, we're just distributing. And for now, we're keeping everything in the summation. And then we're going to pull the summation through the addition and subtraction. Okay. So we get summation I equals 1 to n, xi, yi, minus y bar, summation I equals 1 to n of xi, minus x bar, summation I equals 1 to n of the yi, plus the summation I equals 1 to n of x bar, y bar. We're going to use the same trick as before, and we're going to recognize in this very last piece that I have no i's. So really, I'm just going to be left with n times x bar, y bar right there. And then I'm going to use another trick, and I'm going to multiply by n divided by n divided by n, and I haven't changed anything. All right, let's see what we get. We're going to have the summation I equals 1 to n xi yi minus, wow, this piece right here becomes x bar. This piece right here becomes y bar. And so we're going to get n x bar y bar minus n x bar y bar, looking good, plus n x bar y bar. That's nice, because we are getting very, very close. Okay. The last two terms, well, those just sum up to 0. We are left with summation I equals 1 to n xi yi minus n x bar y bar. So close. Then we can transfer back using the definition of the mean by doing minus n summation I equals 1 to n xi over n times the summation of yi I equals 1 to n over n. And now we are so close. Almost there. Summation I equals 1 to n xi yi minus the summation I equals 1 to n of the xi's times the summation I equals 1 to n of the yi's. All of that is just over a single n. And now you can see that we are done. QED, right? Because we just ended with our SXY equaling the right-hand side. And our proof is finished.